Hi friends, today I am going to discuss slope deflection method analysis. What is the slope and what is the deflection? So, a continuation beam, one end is roll fixed hinge support, another end is roller support, another end is roller support. This is called uh, continuation beam. When elastic core is drawn to the supports the continuation beam, so this is the elastic curve. When I applied the point load here P, the beam is deflected. This is the AB span. So the applying point load here, the beam is deflected uh, something distance, so that is called deflection. Okay, and the elastic curve, the tangential draw a line, this is called the slope. This is slope. So this slope also called rotation, deflection also called settlement. Okay, how to calculate the slope and deflection? By using this method. Okay, this method was given by the G.A. Mani. This method is based on the stiffness approaches, and basic unknowns are taken as a joint displacement, that is theta and delta. Here this is the beam, continuation beam, here the delta, and this is the theta. We can calculate this joint. Okay, to find the unknown, joint displacement, joint moment equilibrium condition and shear equation are written, and joint moment in the members are found by a force displacement relation is called the slope deflection equation. Okay, in this method deformation due to the bending are only considered and axial deformations are neglected. This is the continuation beam. Okay, this is the continuation beam. When a load applied, the beam continues go to the deformation. So this is the bending, deformation bending. This is the deformation bending. This is denoted by a delta. Okay, when a lateral load is applied on a beam, there is going on axial direction. This is throughout the axis is going. So you can neglect the deformation in axial direction. This force is neglected in axial direction deformation. Okay, so this slope and deflection you can calculate by using a simple sign conversion. You can rememberize, then can solve the slope deflection equation derivation, and also many problems you can solve. Okay, I'm take the this is the continuations beam. I'm take the simple span AB. This is the AB span. What is the sign conversion? What is the fixed end movements? What is the rotation? What is the settlement? How to solve this by using a simple sign conversion to can use to solve this. Okay, this is the simple beam. This is the AB span. I'm take the AB span. This is the fixed end moment. First you can calculate it here. First this is the anti-clockwise direction, this is the clockwise direction, is fixed end moment is developed. Here clockwise end movements are taken as a positive and anti-clockwise movements are taken as a negative. Okay, this is the anti-clockwise direction. This is the span AB movement, fixed end movement MAB. This is the MAB. This is the anti-clockwise direction. You can take the negative. This is the clockwise direction BA span. Anti-clockwise direction you can take the this is the clockwise direction you take the positive. Okay, here MAB. This is the MAB. This is the MAB. So taking the negative, this is the anti-clockwise direction, you can take the negative, and BA, this is the clockwise direction, take the positive. This is the clockwise direction BA, and then slope, that is called rotation. Here a continuation beam, this is the elastic curve I am drawing. Okay, in a load is applied here, this is the point load is applied. Okay, the point load is applying, the beam is deflected, that is the delta. Okay, there is something going on deflection, this is delta. You can draw a tangent line, this is called theta. This is the rotation, and a beam is rotating clockwise direction, this is the theta. Here the anti-clockwise direction you can rotate, this is the when a beam is rotated in anti-clockwise, here you support a clockwise direction, support B is the anti-clockwise and support C is clockwise direction is rotated. Okay, on slope rotation take the sign conversion. Clockwise rotation is are taken as positive, anti-clockwise rotation are taken as a negative. Here theta A is the clockwise direction, I am taking the positive. Theta B is the anti-clockwise direction, I am taking the negative, and theta C is taken as the positive and clockwise direction. So and deflection, that means settlement. So when I applying a fixed beam, I am taking the simple load here W. The beam is deflected or settled something deflect delta. So that is the positive or negative how to take here. When a beam is rotated in clockwise direction, that is the positive delta or positive deflection. So those displacement, that is deflection, will be a positive, which produce the clockwise rotation to take the member. This is the member can rotate the clockwise direction of the member is called the positive. Here delta is the positive, the clockwise rotation or to the member, it is called positive deflection. And here those the deflection displacement or deflection will be negative, which produce the anti-clockwise rotation at the member. So this is the fixed this is the rotation is the member is producing anti-clockwise directions taken the negative. So negative, here negative deflection delta is equal to negative. So this sign conversion used to derive the slow deflection equation, and so many problems are solved in later video. Okay, thank you.